Go.
Hello. Nice to see such a big crowd. I guess you already got the intro from Carlos. Today we will talk about an application of graph convolutional neural networks. We had two talks already, two discussions about graph convolutional neural networks. And today will be a rather short paper. It's just about one application. We found this application quite interesting because, well, nPlan works with text embeddings quite a lot. And, well, it's about text classification. And the classification is done by creating embeddings for the text. So in this case, this particular paper is interesting because they train word embeddings and document embeddings at the same time. So usually you would have to train word embeddings using word2vec or any other method, but word2vec is the famous one. We talked about it here many times actually. And then you would train a document embedding, for example, doing doc2vec or one of the other, many other methods available. We will talk about the other approaches here because they have a very expensive comparison. So, maybe complete this. How can I do it? Whiteboard? Thank you. So TF-IDF was discussed because they use TF-IDF here in an interesting way. Cool. So it's called graph convolutional neural networks. So graphs. Graphs are useful everywhere. You know, it's used. You can model so many things as graphs. In this case, they model text as graphs. So they would have two kinds of nodes. Okay, one kind would be a word. Okay. The other kind, let's make it square, would be a document. This is interesting because you see you don't have multiple layers of embeddings, and words and documents would be embedded at the same time. So the goal is to classify both the words and the documents. Okay? Let's go down. I want to go to the top. There you go. So if you look here, diagram, I go back to the beginning. I just want to give you understanding what the model is. If you look here, they have words like cardiac, Doppler, T-cell, and so on. And the nodes that start with O's are the documents. And you see there are links or edges between words and documents. So I will do another word here. Or 2, okay? And you would have links like this. Maybe there is no link here. What's interesting here is that the edges are built from the text. So normally the GCNs would be used, for example, for citation networks. So and the citation networks would have the edges defined in there because they would say this document cites the other document, right? Here, we define the edges from the text. So, the TF-IDF discussed would be used here, IDF of this word in this document, okay? But between two words, well, we don't have TF-IDF, so they use another metric called PMI. Well, the description is there, but to define PMI, we need to define a window. So the window is used in the following way. There is a text, there is a document, they have a sliding window, okay, over the text. To define a fixed size for a window, I think here they used
20.
10 or 10?
20.
20. They used 20. So they would have the sliding window, and then they would define the PMI as the number of the number of windows that contain both word I and J, okay? Divided by I. So
Number of windows. The number of windows.
Yeah, sorry, number of all windows, okay? Let's see the formula to make sure we get it right. There you go. Okay. So this would be the P for I and J. So they would define I and J, and they would also define for each word, which would be the number of all windows. It's all windows, and then the PMI would be the log. This is a mutual information. Okay. Basically, this defines the mutual information between the two words. J, P, I, J. Okay? And then you would put the value as the edges. So that's the graph we define. Okay? Any questions about the graph?
So what does that really represent? This like that formula, the PMI. It's like how
It's a test.
associated the words are with each other.
The words with each other, yes. Well, how frequently the two words appear together? Not frequently,
Yeah.
because there is a log, there is division about how it's in mutual information between two words. Because if you think about the sliding window, if they appear in the same sliding window, then they are close to each other, right?
Yeah. As in the way that that's maximized is if they are in every single window they are together. They're
But
both
nowhere
in every
else.
single window.
Right, but no.
If every time one appears, the other one appears as well,
Yeah.
then that's maximum.
Yeah.
But they don't appear anywhere else without each other,
Yeah.
right?
This is not traditional mutual information, this is pointwise mutual information. So this is the contribution this co-occurrence would make to a mutual information for the entire probability matrix, but we're not looking at that yet.
If one word excludes another, say because they are synonyms or something, that would become zero?
Probably.
Yeah.
Yes.
Yeah. But then you would hope that because they are synonyms, they appear in similar contexts with other words, and then they would maybe
Made it
be
too much,
counter.
so might
That's a good point. I guess because if they are synonyms, they would appear similar.
But remember that what this is trying to quantify is how strong a relationship is between two words. So a synonym would have, this would be very low for two words that are synonyms because it is very unlikely that they will appear together. Just like repeating the same word twice. So what this is trying to do is put a weight on the edge and with something significant, and what this is saying is what is the probability of them appearing together.
Yeah.
Really probability, but so.
It's frequency.
This is the point of that you also like the synonyms kind of to group together. So in the sense, to understand what the document is about, that synonym has to be that's the ideal word embedding. That I mean, you kind of if he's a good writer and he uses many synonyms, then to understand what it's all about, you kind of have to group them together. So how is that?
So that is the next step. This is not learning embeddings yet. This is just building the graph.
This is still just a model. We will we will build the embeddings as a